Okay, this is the second half of section 5.6. In 5.6 we're solving these inequalities. This one is rationals. I want to just look at the graph here for just a second. The first one says, when is f of x equal to 0? Well, we have a problem, Houston, because this is not going to hit 0, this will not hit 0, this will not hit 0. It is never equal to 0. It's no solution, or you could say none. Okay. When is f of x greater than 0? Greater than, well, here is greater than, so that's from negative infinity until negative 2, not touching the negative 2. It's also greater than 0 over here, starting at 2 to infinity. Now it wants to know, where is f of x less than 0? Take a look. Less than 0 down below, and that happens everywhere between negative 2 and 2. I want you to notice that even if I had asked or equal to, it wouldn't make any difference because it's never going to be equal to. So I still wouldn't have brackets. It is never going to touch the vertical asymptotes. It could have x-intercepts where it comes down below if we had a horizontal asymptote other than 0. Okay, so there's the vertical asymptotes are going to change our positives and negatives. It changes from positive to negative a lot of times on either side of the vertical asymptote, and it also would change if it were to come down below, if it would have had an x-intercept. Okay, so two things can cause us to change signs: vertical asymptotes and x-intercepts. So we are going to do the same kind of process, but this one is, I think it's pretty nice, the same kind of process as we were doing before with the polynomials. The first thing I want to look at is, let's consider what makes it equal to 0. So thinking about it being equal to 0, I want to find zeros and I want to find vertical asymptotes, because those were the two things that caused it to change from positive to negative and vice versa. A 0 is when, those are the x-intercepts, it's when y equals 0. We learned in the last unit that y equals 0 means that the denominator will multiply and cancel out, and it'll just be where the numerator equals 0. So it's at 2. Make sure you understand where that came from, okay? Zeros occur when the numerator is equal to 0. The vertical asymptotes come from the denominator. It's where the denominator equals 0, so that's 1. Those two numbers are going to go on our number line, 1 and 2. Don't put any extras on there, it will just cause you despair. The other thing I like to do is remember that this is a vertical asymptote and a 0. That's going to come in important later, okay? Now we're going to check for positives and negatives. I'm going to check in my factored form right here. Okay? So I'm going to take a number less than 1. I kind of like 0 whenever I can use it, so I'm going to put 0 in here. 0 minus 2 is a negative number. 0 minus 1 is a negative number. If I take a negative divided by a negative, I get a positive number. Okay, between 1 and 2 is 1.5. 1.5 minus 2 is a negative number. 1.5 minus 1 is a positive number. A negative divided by a positive is negative. Pick a number bigger than 2. 3. 3 minus 2 is a positive. 3 minus 1 is a positive. And a positive divided by a positive is positive. Let's look at what we were looking for. I want to know where this function is greater than or equal to 0. Where is it positive? It's positive here and here. So we're going to write those in interval notation. We're going to start with negative infinity to 1. 1 is a vertical asymptote. It is never going to touch it. So even though it's or equal to, it is a parenthesis because it's a vertical asymptote. That means this thing is going like this. Okay. Now, over here, it's also from 2 to infinity. The 2 has a bracket because that's the 0. It's where it's equal to 0, and that's what we want. Watch the vertical asymptotes and the zeros. Vertical asymptotes are always parentheses because it won't reach it. Okay? This is probably coming up more like this. So it's coming up through there. Alright, but it doesn't matter what the graph looks like, but we can kind of put that information together for ourselves. Make sure you stop and write those down before you go. Let's go on to one more. We're going to solve this inequality. The first thing we need to do is find the zeros and find the vertical asymptote. I want you to hit pause and put those, find the zeros, find the vertical asymptotes, and put them on a number line. If you feel like everything is going well, then go ahead and check your intervals. Hit pause and go do that real quick. The zeros are where the numerator equals 0, so it's 3 and -4. The vertical asymptote is in the denominator equals 0, which is -1. So I put those on my number line. If all is well, hit pause and go ahead and check your intervals. This is already factored, so I can check my intervals, or check my positives and negatives here. I'm going to put a dotted line to remember what these were. Alright, hit pause and go check them. I'm going to put -5 in here. -5 minus 3 is a negative number. -5 plus 4 is a negative number. -5 plus 1 is a negative number. A negative, negative, negative follows the even and odd rule. This is a negative. Something between -4 and -1. I'm going to choose -2. -2 minus 3 is a negative number. -2 plus 4 is positive. -2 plus 1, negative. Even and odd rule tells me this is positive. Something between -1 and 3. I'm going to go with 0. 0 minus 3 is negative. 0 plus 4, positive. 0 plus 1, positive. That means this is negative. Something bigger than 3. I'm going to choose 4. 4 minus 3 is positive. 4 plus 4 is positive. 4 plus 1 is positive. That is a positive answer. So it's likely that this thing looks like this-ish. Okay, but it doesn't matter. What are we looking for? Go here. I want less than or equal to 0. Hit pause and write your intervals. Okay, I want negatives. I'm going to carefully watch parentheses and brackets. I'm going to go negative infinity to -4. It is a 0. I want to include those. Bracket. I'm going to go -1 to 3. This one is an asymptote. This one is a 0. And there's my final answer. Alright, if that did not go well for you, you might want to try that again. Again, section 5-6, I'm going to have you doing 5 problems in Pearson and 2 problems in the book. I think you'll probably want to start with Pearson because it can help you to determine if you're doing things right. And then redo when you need to so that you can get a better score. And then do the ones in the book and you'll feel more confident. Alright, see you in the next chat.